So we've talked about our binary compounds. So those are going to be compounds that have just two elements combined together ionically. We have multivalent compounds, which are kind of like binary compounds, except a multivalent ion is used in which you have more than one option for charges. Now we need to talk about polyatomic compounds, specifically talking about what are polyatomic ions. So polyatomic ions are going to be ions that are made up of more than one atom. So at this point, we've maybe talked about something like this. We know this is an ion because it has a positive charge, but that isn't the only way we see ions. We can actually have an ion just encompass a whole entire compound. So for example, I have here listed something called ammonium. So ammonium is something that we use in cleaning products. So if you're cleaning your bathroom, a lot of times one of the listed ingredients will be ammonium hydroxide. So it's super toxic, but what it also is a polyatomic ion or a polyatomic compound. So when we have our ammonium, which is a nitrogen bonded to 4 different hydrogens, that whole entire compound encompasses a positive charge. So these typically will act like an individual ion, even though they're not. We know that they're multiple elements combined, but they're going to act the same way a binary compound would if you had 2 different things together. So the charge applies to the whole group of atoms. Now we have a bunch of different ones that I've listed down here. So these are all the common polyatomic ions that we use. So you can see we have ammonium listed there. That is our only one that will act as a cation. All the other ones typically act as an anion. So they're usually bonded to a single cation. And you can see that each of these embody different charges, and some of them have multiple different types. So you can see that with our nitrate and our nitrite, they both have nitrogens and oxygens, but they have a different number of oxygens. And so that's how we get a little bit of difference. So we've named them a little differently. Then you can also see as we get to the bottom, we have things bonded to maybe hydrogen. So we have a phosphate, which is PO4, but we also have a hydrogen phosphate. So the hydrogen phosphate is going to be a different formula. So now what we need to do is practice how we're putting this into a formula. And it's not as hard as you think. We actually are going to just be taking the cation, the anion together, and then doing our crisscross rule. So say we had NH4, which is ammonium, and we have chlorine. So chlorine has a minus charge, NH4 has a plus charge. So if we're doing the crisscross method, we know our cations always go first. So our cation here is NH4. And I'm going to put it in parentheses just to make it more distinct. And I've got my chlorine. And then I'm switching these. So the chlorine has a 1, so that will go here. The NH4 has a +1, so that goes on this side. So we actually just get NH4Cl. So you can see that I took away that parentheses just because it's not super necessary in the actual formula. It does become necessary if you have a subscript added to your polyatomic compound or a polyatomic ion. And I believe that second example is going to explain that a little better. So for that next one, we have chromium 3. So that's a multivalent compound. and we have SO4 2 minus, which is called sulfate. So what we're gonna do is we'll write out our cations. So we just have Cr. We know the 3 is telling us we have a 3 plus charge. Then we have SO4. I'm gonna draw parentheses around it just to make it more distinct. So we know it's gonna be crisscross. So the 3 is gonna go on this side. This 2 is gonna go on this side. So since we know we're gonna have multiples of the SO4, that's when you'll need the parentheses. So the 2 is gonna be with Cr, so we have Cr2. And now I'm gonna put this in parentheses because we have SO4, but we are going to have 3 of them. So SO4, 3. Okay, so for that last one, we've got copper 2. So the 2 is telling us what charge we have. And we have hypochlorite. So what you'll want to do is look up what hypochlorite is in that table above. It should be up there somewhere. I'm not going to do this one on camera. I'm going to let you guys do that yourself. Then we'll do practice. And then we'll move on to the next thing, which should be covalent compounds. All right.